All right, guys, welcome. We're going to go through finishing our simplifying trig expressions packet, starting off with using some Pythagorean identities. And you really want to know, obviously, your first one, sine squared plus cosine squared equals 1. But the alterations to them using, to simplify secant squared of x minus 1, you can simplify that to just tangent squared of x, using one of our other Pythagorean identities. So if you see a squared trig term and a 1, think about which identity you can use, if you can use one. Second one here now, notice cosine is not squared right now, but I have two binomials. So in number 11 here, I'm going to FOIL this out. When I distribute that 1 in, you get 1 minus cosine of x. And I distribute the cosine of x in. And notice the last term, when I multiply cosine of x times cosine of x, I get cosine squared of x. The nice thing that happens here is I've got a negative cosine of x and a positive cosine of x that'll just cross right out, leaving me with 1 minus cosine squared of x. And again, Pythagorean identity I can use makes that sine squared of x. All right, so definitely simpler there. Continuing one more. All right, now I have number 12, 1 minus sine squared of x. That I can rewrite, I know right away, as cosine squared of x. And then I see a 1 plus tangent squared of x. So I gotta think, let's see which Pythagorean identity I can, I can just use that to rewrite it as secant squared of x. Once I do that, I can continue simplifying, but cosine squared of x is already in terms of sine and cosine, so I'm going to rewrite secant squared of x as 1 over cosine squared of x. And when you multiply that, that's like cosine squared of x over 1. Those are going to cancel out. That's just going to leave you with 1. Nice, neat, easy. All right, so it's really good to know as we continue into our next kind of phase with our trig expressions, it's really good to be able to pick out those Pythagorean identities pretty well. All right, this video is going to contain these next two little tricks I want to show you, and then the rest is going to be practice for you. So the first thing is adding fractions with different denominators. So if you have two fractions, different denominators, what you must establish is what the LCD is. LCD is the least common denominator and must contain all the denominators. So 1 plus cosine theta and sine theta. That's your LCD in this case. And what that means is the left fraction there, I need to multiply it by something that's going to give me the full LCD on the bottom, which is going to be just sine of theta. On the top and the bottom, though. You can't just do it on the bottom. And the same idea in the second one, I'm going to multiply by 1 plus cosine of theta because I need that to be included in the denominator. Okay, when I do that, I will have the full LCD on the bottom of the left, and on top I will have sine squared of theta. On the right fraction, now I'm going to distribute this cosine of theta in to give me cosine of theta plus cosine squared of theta. And then again, that's over the LCD. Great. Now I have the same denominator, which is wonderful. That means I can add the numerators together. And what I'm going to do is I'm just going to flip the order of these so something can jump out a little better for us. So all I did was flip the order of what I'm adding there. And added the fractions together. You can probably pick out the reason why I flipped them is because this is a really nice one here. Sine squared of theta plus cosine squared of theta. That is just 1. So that's going to get me 1 plus cosine of theta over, again, the LCD and something else awesome pops out. Those are two binomials that will cancel each other out, leaving me with 1 over sine of theta, which is cosecant of theta. So a lot of steps to kind of get you there, but the general idea of adding fractions with different denominators is all about getting an LCD. Okay, one more problem. This one's going to be a quicker one, and this is a really helpful tool sometimes. Rewriting as separate fractions. And what I'm talking about there is when you have a monomial, a single-term denominator. So, for example, if 10 was a denominator, and I had 3 plus 5 on top. So we know that would be 8/10. Okay, fine. But what I can do is rewrite that as 3/10 plus 5/10. When you have a monomial denominator and a binomial top, you can rewrite them as two separate fractions. See how this works here. I can rewrite this as cosecant of theta, cosecant squared of theta over cosecant squared of theta minus 1 over cosecant squared of theta. You might be wondering why I did that. Well, the first thing I see is going to become 1. So that's nice. The second thing I see, 1 over cosecant squared of theta, is sine squared of theta. And the reason why that's really nice is because that is just cosine squared of theta. So it's a really helpful tool sometimes. You have multiple paths of how you get there, but this is a nice tool to kind of have in your back pocket to use when you need. All right, good job.